Now let's go for the another term, velocity. You are going somewhere in your friend's party, right? And you are looking to the car's speedometer. Your car showing like 80 miles per hour and it's moving in the east direction. So velocity is rate at which displacement is changing. Velocity is rate at which displacement is changing. So we can write velocity as, velocity we can write, remember we are talking when velocity is constant, right? So velocity we can write change in position over change in time. Change in time. So now students, we can write V as delta x over delta t. That means if it travels 50 meters, so to travel 50 meters, how much time it took? That's the change in time and change in position. And if you are going to take the ratio of that, that will be our velocity. That will be rate at which displacement is changing. Now, when there is no acceleration, that situation is the constant velocity, right? So students, we have V equals delta x over delta t. So can we write it as delta x over V delta t? You have to remember, you only can apply this when there is no acceleration. Velocity is constant. I hope you are going to remember this when we are solving the questions. Now students, come to the next term, speed. You are going somewhere, you are looking to the speedometer, right? What that will say, show you? You will see instantaneous speed, and that instantaneous speed will be the how fast that car is moving or object is moving. That's the instantaneous speed. We have another term, average speed. We have another term, average speed. Students, average speed is distance over time. Like if you are going one city to another city, what will happen? Somewhere you will be moving fast, somewhere you will be slow, right? So overall, how much distance you have traveled and in how much time you have traveled, that will be our average speed. I hope you understand. And now we are going for application of these concepts. And also we can discuss one more thing. When you are going in a car somewhere, speedometer is showing something, then that will be the speed, right? How fast an object is moving. And if we are discussing one-dimensional motion and a car is moving on this unidirection, direction, and we are taking this direction as positive, right? X direction as positive, and this car is moving with 10 meter per second. So what will be the speed? 10 meter per second. And what will be the velocity? That will be the plus 10 meter per second. That plus is showing us what? Direction. That plus showing us direction. Now students, if this car is moving in a negative x direction, there is another car B that's moving in negative direction with 20 meter per second, then if we have asked about the speed, then our answer will be 20 meter per second. But if we have asked about the velocity, then here direction matters. We are going to take negative direction as negative. So we are going to say here velocity is minus 20 meter per second. That minus is showing us direction, negative direction, that this car is moving in the negative direction. Let's take some examples. Example A, Mario drives a go-kart around a circular track with a radius of 20 meter. What is his a displacement and a distance traveled? So students, let's take this as the Mario's circular track. If Mario is going to move from here to here, started from this position, initial position is this, and also this is the final position. So students, what will be the displacement? What will be the displacement? You are going to say, since initial and final position is same, displacement will be 0. Displacement will be 0. Why displacement is 0? Because initial and final position is same. Now students, think about the distance traveled. Is distance traveled is 0? Think about the distance traveled. So you are going to say no, distance traveled is not 0. Distance traveled will be this path length. So what will be this circular path length? Circumference of the circle, and you know it's 2 pi r, and we have radius as 20 meters, so we got the answer as 40 pi meters. That will be the distance traveled, right? Let's take another example. Under what condition will an object have a distance equals to its displacement? Now brainstorming is, in what condition distance and displacement will be equal? Look, we can take the example of 1D motion. We can take an example of 1D motion. Let's take a particle A is moving like this, going somewhere this position to this position. Second, we can take a particle is moving like this, going here to here. Third example we can take, students, this time not 1D, let's take 2D. This was the case of 1D. Now let's take the 2D. Particle is going on this path. Now think, in the first case, if you are going to compare magnitude of distance and displacement, you will see this will be the displacement. This will be the displacement. And distance is the path length. So if you are going to compare in the first case, displacement's magnitude and distance, so which one will be bigger? Distance will be bigger, right? And if students, we are going to compare in the second case, this time displacement and distance have the equal magnitude. Distance and displacement have the equal magnitude. Now go for the third case. Here this path length will be the distance, right? But displacement will be this. This will be the displacement, right? So in this case, if you will see, distance is bigger than magnitude of displacement. I hope you understand these two differences.